Well, in this video, we're going to be discussing the inverse trig functions, of which there are three that we study, and kind of talk about the rationale for having them around, or why are they useful? Okay, why are they necessary? Of course, we always need inverse functions given a certain function. We like to have its inverse. So we're going to start with this situation. How about we had a triangle, okay, and we'll say this triangle is a right triangle. That's convenient here, but the good old 3, 4, 5. That's a good Pythagorean triple. What if we had a 3, 4, 5 triangle and we say express this angle down here as theta? Now, the fact of the matter is this is a right triangle, and maybe I should label the sides here. We'll call this A, B, and C. You know, and A is measure angle. You know, the measure of angle A is theta degrees. But the fact of the matter is this: we only know really vertex A, its angle. We don't know A and B. So if I were to say find the angles in this triangle, it would be very, very difficult to do because we only know one of them, and that's the 90-degree angle. So one thing we can do, however, is we could say, well, we happen to know that whatever theta is, if we were to take the sine of that, it'd be opposite, say, over hypotenuse, which in this case is 3 over 5. I'm going to go ahead and change that to decimal form, which would be 0.6 in this case. You know, we'll talk about, you know, it's easier to use a calculator, but the fact of the matter is this: we've got sine of theta actually equals 0.6. Now, let me go ahead and show you the mistake in people's thinking right off the bat, and you see this a lot. You know, well, we've got to get theta by itself here, and theta, you know, is with the sine, so maybe we can do this. We can divide both sides by sine, and that'll cancel out, and theta equals 0.6 over sine. And I want you to think about this now. Now, sine is no more than this idea that given an angle, we are going to head opposite it and take that length, and we're going to take that length and divide it by the hypotenuse length, which gives us some ratio, okay? So sine itself is actually a function. It's a rule. It says give me an input, give me an angle, and I will tell you how the opposite side compares to the hypotenuse. That's all it does. That's its output. So we are not actually taking theta times sine. We're taking the sine of theta. So very, very important here. We realize that. So what we're going to have to do is we're going to have to find a way to undo sine. Okay? And so it's at this point we're going to introduce this idea of a new function. Okay? And so we say the inverse trig functions. Let's go ahead and list these over here. So inverse trig functions. I probably wrote that as the title now, didn't I? Inverse trig functions. Okay? The three we discuss primarily are sine with a little -1 here. Sine little -1. Another name for this is arc sine. Okay, it's related to the arc on a circle. But sine or arc sine, I will be honest with you, you know, we typically say this sine right here. So let's go ahead and write how you would read this. You would read this as sine inverse, okay, of whatever it is you're taking the sine inverse of. Okay, we have inverse cosine, cosine inverse, or arc cosine. You'll see that on a calculator sometimes. And we have tangent inverse. Tangent inverse, which is arctan. Arctan. Okay, or arctangent. The fact of the matter is this, though. Tangent inverse undoes tangent, okay? And tangent undoes tangent inverse. So it is very fair to say this. Given an angle theta, it is the case that if we were to take the sine inverse of the sine of, say, theta, you know, I'll redraw that, it's kind of sloppy. Sine of theta, these two sines, they would cancel each other out, and you would just get theta. And that is equivalent to saying, well, what if we took the plain old sine of its inverse, sine inverse of theta, okay? These sines would also cancel out. So, yeah, let's go ahead and write the rest down. And sorry about the red strikes there through those, but it is the case that, oops, we don't want red, we want green. I think it's green. And we want cosine. So the cosine of cosine inverse of theta would just be theta, which is what we want. We want the angle, okay? Which is the same thing as saying cosine inverse of cosine of theta. And those cosines would cancel. And likewise, we say tangent inverse of tangent of theta is just theta because the tangents cancel out, excuse me. That's the same thing as plain old tangent taken of its inverse, tangent inverse of theta. Okay. So that being said, let's go back to our original equation here. We said we got a sine here. We got to undo the sine. I started drawing a parenthesis here. I'm putting parentheses around the entire left side, but I'm going to say I'm going to take the sine inverse of this. Now the important thing is if you take the sine inverse of one side of an equation, we really did it to the other. So that sine inverse, as a matter of fact, has to go out front. Okay, a lot of my students like to write at the end, so it says 0.6 sine inverse, and that doesn't make sense. We're taking the sine inverse of this thing. Okay, excuse me. So over here in the equation, of course, like I mentioned, the sine inverse will cancel out with sine, and you're just left with theta. All right, that's awesome. So theta equals, we need to take sine inverse on the right of 0.6. And the neat thing about this is we don't really have to do much. I've got a calculator that's going to do it for us. Let's go to my dashboard here. And depending upon your calculator, you'll notice mine says A sine, A cosine, A tangent. This stands for arc sine, arc cosine, arc tangent. And there are different calculators. They'll have the sine inverse is sine to the -1 kind of thing. But we need to take the arc sine, so sine inverse of 0.6. So I'm just going to type in 0.6, and I've got my calculator set here on degrees. If I type this in, I hit enter, you're going to see it looks like 36.869. You know, we talk about degrees. It's usually good to go out to the hundreds. But, you know, I always ask people to go to the thousands. You know, it's pretty accurate on at least our scale of things. So 36.869, and this is an angle, okay? So when I say 36.869, I'm saying theta equals 36.869, and that is in degrees, okay? I hope I didn't have to round that 9 up because I wasn't really paying attention. But 36.869 degrees. So now if I were to go back up to the original triangle, 36.869, that's entirely reasonable in terms of an angle. And here's another good thing. We know B is complementary to A. You know, we've been commenting on that relationship between the two acute angles in a right triangle, but it must be complementary. So if we were to say 90 minus 30.869, why don't we go ahead and do that? So see, 90 minus, we got this, 36.869, booyah. 53.131. So I'm going to go ahead and scribble that in. So 53.131. You know, that's really sad. I should have been doing that in my head. So anyways, we've got this. Let's go ahead and check this out. How could I determine the measure of angle B? Well, let's pick a trig ratio. We're lucky enough to know all three sides of this triangle, but if, let's say I pick sine again, or how about cosine? Cosine of B. So cosine of B actually would be adjacent over hypotenuse, so 3/5. So the same thing when we took the sine of A, because these are co-functions of complementary angles. But let's say I wanted to get B. Just B. I just want B. So what we'll do is we'll take the cosine inverse. I'm going to rewrite it this time. Of everything on the left of cosine of B. And that is equal to the cosine inverse, or arc cosine of everything on the right, which is 3/5. Okay, so now our cosines gone. They cancel, and we're left with B equaling cosine inverse, whatever this is, of 3/5, which is 0.6. So let's go check this out. So B is approximately equal to, oops, wrong button again. That's contrast. 0.6. So we say our cosine of 0.6 is 53.130. So, you know, maybe I did need to round the 9 in the last instance. That's why I'm getting 131 up here. But the fact of the matter is, yeah, these, you know, inverse functions, they just undo the original functions and allow you to get at angles. They allow you to crack those open. So it's a useful tool. Check it out.